Recording. Today is August 8th, 2019. This is the last regularly scheduled class meeting of ITSC 2309. Tracy, are you speaking?
I wanted to tell you that yes, I can hear you.
Oh, well, that makes my day, huh? Yeah, I got everything up and running here. Okay, last scheduled meeting, and just for your information, and I sent it out as an announcement, and I see I'm collecting a few. I caught up the grading, and then I opened the uh, uh, modules for late submissions, and I said I will grade one submission from everybody. Um, Basically, my whole reason for timing them out was to keep from getting just this huge uh, uh, bubble of submissions right at the last minute, essentially a baby boom of submissions. Um, and seems like I would always do that. So I started timing them out, and then I say, okay, I'll take some. I'm not trying to be trying to make life difficult on you. I'm just trying to get it where I can live with it. The final is up and available. I believe it is. Let me double check. So the final multiple choice and coding portion are open, and you guys get with me right away if anything if you can't see anything. I need to know about it right away, given that you're going to take the, I don't know, edit that. The final is optional if you are fairly happy, particularly if you're happy with test 1 and test 2, and you have everything turned in, you're probably in pretty good shape. You don't need to take it. It is considered a grade builder. If you are looking at the grades and you want to know, well, what is my grade? You have to be sure that you go through, and any grade that is not, any assignment that does not have either a grade or showing that it was turned in. Okay, I don't have to have graded it. I mean, if you've turned it in, then it's I have it. But you should count it as a 0, if just for counting for averaging up what your grade is. What else? The final exam is available now. You may take it when you get ready. You should sit down and do it in one setting. I do not intend to rigidly enforce a 2-hour or 2.5 or 3-hour, whatever, time limit. I just want you to sit down and do it. I don't have it spanning overnight or spanning 3 or 4 days. The test is available until, let me just double check that when it times off. Well, I just had it there and dropped it. August 13th. And I believe this one goes until August 13th. So August 13th is the Tuesday. So the 12th and the 13th are the official days of the finals. I'm leaving things open until the 13th. I'm asking that we get late assignments submitted by the 12th so that I can get them graded. So I have a little bit of a grading pad there. So I'm not accepting late assignments after the 12th. And if I accept it on the 13th, then I'll grade it. But most of them I've got timing out at midnight or at 11:59 p.m. on August 12th. And so much for that stuff. Okay. I don't have a whole lot to say. I left you with some stuff that we were talking about, the third normal form. database normalization. Next. And I gave you first normal form. Well, first normal form, the thing to think of with first normal form is it has to have a key. Everything depends on the database key. Remember, it cannot have any duplicate records. Everything depends on a key. There is a key that will access it. It should be one field. It does not have to be one, but one is what I'm going for. Second is everything has to depend on the whole key together. So if you have a two-factor key, and it doesn't really need a two-factor key like the one in invoice line items, that one violates the whole key. They have stuff in there that doesn't depend on the entire key. And then finally, there should not be another field that acts as a primary key. And sometimes, let me see if I can pull that up. Sometimes you'll find that going all the way to the third normal form, is a little difficult to do. And for example, if I have a table that has a social security number, driver's license number, and state. Okay, so I would probably make the primary key be the social security number, I guess. The driver's license number and state are also a key to that table. They together could be a primary key. And to be in third normal form, I should move those out to another table. And sometimes that's just too much trouble. So usually we'll settle for a second normal form. Got some examples here. I'm not going to go into a great deal of detail here. I ask you to use this, and I ask you to design some tables. Let's see, in the exercise here, I ask you to, let me see if I can pull that up. Exercise, okay. I'm wanting you to design a database diagram. And again, this can be done. You may do this in SQL language. In other words, you may use create table and just come up with some good tables here. Or you may do it in Word, or you may do it with some what is the primary key and foreign key. Let's see, you may create other tables. Let's see, design a database for the 4 tables, indicate the relationships. And let's see, customers. So I've got customer ID referencing customer ID, order ID referencing order ID, product ID referencing product ID. So I think under order line items, I believe this is going to be a many-to-many relationship. So an order may, a customer may order many products. A product may be ordered by many customers. So there we have a many-to-many relationship. Ask you to add 2 additional tables, and I'm really looking for the explanations here. So this is kind of sometimes this is kind of like writing an essay. Okay, well it really is, but you're talking about the task of designing a database. I see I'm getting a couple of these turned in, and it's okay to turn it in as a Word document or as a scanned document, however it works out for you. You may turn it in either way. Questions? Okay. Well, with that, I'm going to say that the material that is part of 2309 has been covered, and I'm going to step out of 2309 right now, and I'm going to step into the next class very briefly. So don't worry about it. Now, if you don't feel like, if you're not going to take the next class, then you are free to go on and just go do the final. I'm going to step into what we're going to talk about in the next, no, I'm going to probably talk about 20 minutes on it. So I'm not going to spend a whole lot of time. I don't like talking about taking a class 2309 and then spending all my time talking about the next class. I don't like teachers when they do that, but I think it's a good idea a little bit. And right up until now, we have been using this little window here where our code is. So we would put our select from where statements in here, and then we hit our little execute button. And if we have a bunch of statements in here, they all get executed. And that's fine. And that's what it does. But this is really a lot more powerful than that, because this is a programming environment. Now, when I create a select from where query, any kind of a query, basically it is just a text file that is stored in my computer's space. So I save it as an SQL file. I can load it back into my my little text editor here, and I can execute it anytime I want to. And then we get to the idea of the view. And now I can take a select from where query, and I can save that select from where query as a view. But it is still saved as a text rendition. So while it's not exactly, it is a program in and of itself, it's what we call a batch program, meaning it has to be executed line by line every time. Now it's encrypted and encoded such a way that you can't get to it when you save it as a view. So it's a nice security idea, and it lets people run stuff without having it, but it doesn't really quite, it's not true programming yet. And now we're just about to step into our first SQL program. And the language that is, there is a language in all databases have it. And so in SQL Server, the language is Transact, R-A-N-S-A-C-T, Transact SQL, or T. Many times they'll drop that, instead of calling it SQL, they'll call it T-SQL. So SQL is not entirely correct, because there is another language, a real language, that is named SQL, but SQL will many times get called SQL. So just I'm just over it. In Oracle, the language is PL, programming language, SQL, PL/SQL or PL/SQL. And it's actually much more powerful than Transact SQL or T-SQL. And it is a derivative of the programming language that is known as Ada, or the programming language that is known as Pascal. So it inherited deeply from these two. And so PL/SQL is the proprietary language for Oracle. Now, all of these things are different, and every one of these things is a different syntax. So up until now, I have tried to teach this class such that we can pick up anything from anything that we have written. We should be able to pick it up, drop it straight over into Oracle, and it should, in theory, run. Now, I'm not silly enough to think it would. if we picked everything up and dropped it over there. It wouldn't, of course. We'd have to tweak it because every SQL language is a dialect of SQL. But in theory, it would. It would be a little bit like someone from the Texas talking to someone from the Caribbean with a thick Texas accent and a thick Caribbean accent. Okay, so what I want to do first is I'm going to create a program. So the first thing I'm going to do is create a compiled program. A compiled program means that it is not stored. I do not store this code in my computer. I store the binary code that does this. So I'm going to create a procedure. The procedure is, this is a computer program. The name of the computer program that is stored in my database will be named Hello World, surprisingly enough, because I'm sure you've seen this one done before. Hello World. And then we have a begin and an end. I believe that if you only have one line, the begin and end are optional, but I always use it. I'm not sure whether it's optional or not, because I always use it, and I strongly suggest that you do. And then in between the begin and the end is one or more statements that do something. Okay, this one just has one statement in it, and that statement prints a message to the screen, Hello World. I could have said select Hello World. In that case, I would have gotten back the table. It would have returned to me the table that had one row, one column, and that column would be a varchar, and it would have in it Hello World. But if I say print, then this is an executable statement that just prints it to the screen. So if I execute this guy and say create or alter procedure, and this is real nice because I can say create, I don't have to worry about dropping it each time. It would be nice if we had a create or alter table, wouldn't it? Unfortunately, we don't. I don't know why. We don't in any language that I know of. But create or alter procedure, we typically do have. And when I say execute, it says it completed successfully. And what that means is that this procedure now exists. So if I were to go over in my views, my Object Explorer, and let's open it up. I guess I'm connected. Okay, I'll get that way if I'm not. Now I'm connected. Okay, and since I created it, I hope I created it in Scratch. I may have created it in, I'm gonna go ahead and drop it. I think I created it in, I keep after you guys about it, AP. So I have to execute that use Scratch, otherwise it's going to create it under APDB. So now I have created it, and now if I go look under Scratch, and under programmability, this is a program, and under stored procedures, I find the procedure named Hello World. I can execute it over here. I don't have to do that. I can just execute it. I say execute Hello World. Now, I have a create statement in here, a create statement. Remember, create statements start with go and end with go. So I should bracket it with go. Once I finish with him, once he is created, now I can execute, EXEC, or I could write execute, Hello World, and I have just run my first program. Yay, everybody says. So we have run the first program, Hello World. For some reason, that's always the first one you write, which it makes sense because it shows you how to get something compiling. And this will stay there forever until I drop it. And I can give other people, other users, the authority to execute my procedure. for example, I could, well, I'm going to show you one other example of it. So now when I'm done with it, I don't want it to hang around forever. So I'm going to go ahead and drop it. Notice it still shows over here, but that's because this doesn't update dynamically. So just because it's still showing over there, if I refresh it, it should go away. Refresh. Close him. Now I refresh. And now he's gone. Okay, that's fine. I'm not too worried about him. I just I don't want him cluttering up my memory in the database. I'm going to reinstall the database anyway, so it doesn't matter much. What else can I do here? Okay, I can create a procedure, and this procedure can receive parameters. And in a I don't know how deeply to go into this, but I'm going to call this one hello person as opposed to hello world, because this procedure will receive two parameters. Now, a parameter is a variable, and a variable in TSQL always starts with that @ sign. I guess that's an @ sign. I don't know what its formal name is. I guess I just call it an @ sign. Anybody know what the formal name of this guy is? Let's see, @p. And so I begin all of mine with @p, and that tells me that it is a parameter to this function. So @p fname, @p lname. Okay, so I'm passing it a first name and a last name. And the p tells me it's a parameter. And so when I run it, so when I say create alter procedure, this procedure will take two parameters as begin. This one is going to print hello, and then it's going to print the person's first name, and then it's going to append to that the person's last name. So let's see if it will work. Execute it, and it did create it successfully. Now, when I'm ready to execute it, I can say execute person, hello person, Stephen, comma, Smith. And so I'm passing the parameter Stephen into the first name because the first name is the first parameter. Smith is the second parameter, and this is called passing parameters by position. Most programming languages pass by position. TSQL allows you to do either one. So I can either match the positions that in which I created them, create or alter hello person. It's expecting a varchar 16 in the first position, a varchar 16 named lname in the last position. I don't care what their names are. And so when I execute these, I get the message, hello, Stephen Smith. I can also pass them by name, and I say execute hello person, p lname. Notice that I've changed the order of them here. I'm saying pass the last name first, BLOE, p fname Joe. So this I'm passing the procedures by the name of the procedure. So p lname and p fname, and I could have passed them in order or not in order. Now the order doesn't matter. So notice that one of them, hello Joe Blow, one of them requires that you pass them in the correct order. The other one requires that you know what the names are. So you have to know something about those parameters before you can use this subroutine. I don't know what would happen if you tried to mix and match pass by position and pass by name. I doubt it would work. Questions, briefly? Don't want to get too deep here. I'm going to drop this one.
But thank you.
Okay. What do I have here? Okay, a parameter can bring information in, for example, pname. It can also give information out. It can be an output parameter. Different programming languages handle this differently. I'm not going to go into the way others do it, but the second parameter there can be changed. So up here, if I tried to change the first name or the last name inside of this procedure, it would not have worked. Most of the time it will generate an error. Sometimes it just ignores you. Idiot. It just doesn't do anything. This one creates the procedure. Now I will be able to change the second parameter because I have declared it to be an output parameter. That means that it takes information back. It can also bring information in, but basically it's an output parameter. So what do? I set the parameter len to be the length of the name. So whatever I pass you as the first parameter, this one gives me back the length in the second parameter. Let's see, declare, I don't know what I'm doing here, declare a number, okay, numchar. So I have to have a variable. If I want to pass this back, I have to pass a variable in that position. I can't pass under PLEN, I cannot pass like 23 because I'm going to change this thing, so it doesn't make any sense to pass it the literal value 23. So I'm going to execute name test. I'm going to pass it Stephen as the first parameter. That's okay. It's just a varchar. And as the second parameter, I have to pass it a variable. Okay, here's the variable. I declare a variable named numchar. It's an integer. And I'm passing it in as an output parameter. That means it can be changed. And then I'm going to print the value when it comes back. So let me go ahead and execute this. Okay, what's the matter? Cannot perform alter on name test. Probably because I have a table named, yes. I have a table named name test that that's the, now it'll work. You have to be careful. That's one of the problems that we're going to encounter in the next. We're going to have lots of names floating around, and unless we have some way of keeping track of them, it's therein lies madness. So now I'm going to create it, execute. So it created this procedure named name test. So I'm going to declare my integer. Now, I have to do this all at once because I have to say go, then I have to declare the integer. If all I do is declare the integer and I say, okay, declare the integer, here it is, I say execute, everything's fine, but now the integer has just gone away because the program's over. So I have to start, declare the integer, and then execute the program, then print numchar. And there are 6 characters in the name Stephen. Now, if I want to test it the other way, this way is by name. So name test PLEN, numchar, this time it's passed first. Notice that I have to say, when I call it, I have to say it is an output parameter. This is to save you from yourself pretty much. So Hayo Silver is what I'm passing. Should be 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm expecting to see 12 characters, and I do see 12 characters printed. We'll go ahead and drop the procedure if there are no questions. Okay. Okay, believe me, I'm gonna wrap this up pretty quickly here. And none of this is going to appear on the final exam or anything like that, so you don't have to worry about it. Just this is programming, and these are our first true computer programs. So these are stored as encoded data, binary data, zeros and ones, command computer commands stored in the memory of the computer. I believe you can also store them on a external storage, but they're usually stored in the database. Okay, how do we do this? What does this mean? Why are we doing it? I have a object ID pets, drop table pets, drop table owners, create table owners. Well, remember we did this. So an owner has 0 or more pets. And basically nothing new here. I have some constraints in there. The name of the game in database programming: never ever violate a constraint. But you can't violate a constraint. Never ever try to violate a constraint. Your code should protect those constraints. The constraints are your last form of defense, last level of defense. If you can do it, you would rather keep the floodwaters back from your levee by holding them back before they ever get close to what you're trying to protect. So the farther back you can keep the danger, you don't want something hitting this with a bad primary key. So here is the procedure. Now, I'll give you a copy of this, by the way. This one, create or alter the procedure, insert owner. I'm going to insert an owner into the owners table. What gets inserted? When I say insert owner, what do I have to have? I have to have the owner ID and the owner's name. Okay, owner ID 1, name is Joe. Okay, whatever. I have an owner ID, I have an owner name, and I have another variable here called @error_level, which is an integer, and that is an output. So what I'm doing here, and we're going to do, this will be one of the first topics of the advanced class. I don't want anything to fail with an error message. I don't, we have a saying that error messages are your friend, but I do not want these procedures to throw errors. I want them just to go ahead and fail and communicate to you what happened through this variable, the error level. So this guy is going to insert the owner ID and owner name into the owners table, and it will return an error code. If it returns 0, everything is fine. Error level is 0. If it gives you back a 1, that means that the owner ID was null. If it gives you back a 2, that means the owner name was null. And if it comes back with a 3, that means you have a duplicate primary key. Now, I'm not going to use these table constraints to get that. I'm going to check it first. So create this procedure, and when I finish this, I'm going to wrap up here. As begin. I set my error level to 0. There's other ways to do it. By the way, this is known as ladder, L-A-D-D-E-R, logic. So set it to 0. And now I'm going to start going up the ladder. If the owner ID, this one, is null, set the error level to 1. We are done. Nothing else happens. And the person who calls it gets the 1 back in the variable. Else, if the owner name is null, set the error level to 2. So notice that I checked those things that I could check by just looking at a variable. It's either a 1 or a 2. And I thought, okay, if it's one of those, that's simple. All right, now I have to go into the database. Else, if exists, select everything from owners where owner ID is OID of the table, this guy, equals the one we're trying to insert. By the way, no semicolon goes here. If it exists, if something is in there that exists, if something is in there that would cause this, in other words, does that key, does that owner ID already exist? If this is true, this comes back true, I set the error level to 3. That one cost me a little bit more because I had to go into the table and search the table with a select from where statement. Notice that I'm programming using if-then-else logic, and inside of the if-then-else logic, I have a select from where statement that is giving me the information that is driving this logic. So else everything is fine. Insert into owner ID, owner name, values, and the values are those variables. So I'm not I'm using variable names, but I've checked them. I've checked that this one is not null. I've checked that this one is not null, and I've checked that the first one does not already exist. So I should not have any errors coming from the database. If I get errors from the database, I don't like that. Something is wrong. Okay. The return statement is optional. I don't know. I never treat them as optional. Well, return and end essentially do the same thing. Return says, okay, the logic is finished, and end has to be there for the code. So if you don't put a return and you hit the end, it returns. You could conceivably, some people will say, if owner ID is null, set error level is equal to 1, return. So they'll put a return right here. I don't care for that as much as having it at the end of the logic. Notice that if any of these are true, this is what makes it ladder logic. If this guy is true, that's the last thing we do. We set the error level to 1, and we don't do any of the rest of it. Well, we hit the return and the end, and that's it. If the owner name is null, we set the error level to 2, and that's the last thing we do. If I find that it's already in there, I set the error level to 3, and that's the last thing we do. Else, I insert the value into the database. Now, here's a question. What is the error level here? Line 121.
0.
Yes, because it's I set it to 0. I personally like this logic. I consider this as nice, clean ladder logic. I set it my default return as 0. If nothing changes it, it stays 0. When I get to the end, it returns 0. So this would be working code that would check everything. And if I gave you this procedure and I gave you the right to execute this procedure, you would be able to insert an owner into my database, and you would not be able to see or use or even see that the owners table exists. You do not need to know the name of the table. You do not need to know anything about that table. You can execute this procedure from a web page, and this is how a web page interacts with the database. The web page, I don't trust web pages. Why don't I trust web pages? Because they get knocked over very easily. A web page has to answer the door. Therefore, it's vulnerable. It just is. So I don't have any of the code in the web page that accesses the database. The code that accesses the database is buried in these compiled procedures that are hidden in the database. The only thing that you can see in the web page is you can see the name of the procedure. You are allowed to execute this procedure. You know this information right here. You know the name and the order of the parameters, probably, because you might want to call them by name. You might want to pass them by position. It doesn't matter. You have to know about the output. And then you need to know what these error codes are. So this is the information that you need to know to use my procedure. You need to know its name and this information right here. The order and the name, or either the order or the names of the procedures. I usually give them both. And then you need to know what the codes are that it's giving you back so that you can give good information to the web user. So the database never talks to the web user. The database doesn't do much talking to the web page. The database sits there and the web page takes the information from the user, puts it into a correct call to this procedure. And here is a correct call. Where is it? Oh. Here is a correct call to the procedure. Insert owner, 1, Joe, and the error code. And so what is the error code that comes back? So, okay, this one should give me back a 0 for the error code. So if I run these guys and I'll let you go ahead and run them. So inserting the pets is a little trickier. I have 1, 2, 3, 4. Notice that I have a foreign key in this one that I have to check. So success is 0, null primary key, null pet key, duplicate primary key, and I have one more, an invalid foreign key. So I have to check that. I check the pet ID the same way. If it's null, it's a 1. If the pet name is null, it returns a 2. Else, check to make sure that the PID is not already there. If it is, send it a 3. I don't know why I put returns on these. I think I'm just showing here. I think I'm just showing how you do it. If you wanted to do a return after each one, you would have to say begin, set error level 1, return. This is legal and there's nothing wrong with it. It's just a little more verbose. And it'll get plenty verbose, trust me. Else, well, if not exists, this is the one that checks the foreign key. So this one says if not exists, select splat from owners. Remember, so we're inserting into the pets, but I'm going to go check the owners table, check and make sure that this OID exists there. If it does not exist, if not exists, I'm going to return a 4, and a 4 is an invalid foreign key. Else, insert. And in this case, I set the error level to 0 because I did not set a default error level at the beginning of this one. So this one has an explicit return, and this one, so this one does a return each time, and at the very last of the ladder logic, I do the insert, and then I set the error level to 0. There is nothing particularly good or bad about one way of doing it or the other. Lots of ways to write ladder logic. Some things I say about ladder logic, and I will leave you with this, and I promise I will. I check the things that are cheap first. It is cheap to test if the PID, meaning all I have to do is look at this parameter. If it's null, oh well, pet name is null. That's easy. That's cheap. This one, I have to go look at the pets table. That's a little more expensive. On this one, I have to go over and look at the owners table. I don't know if that's any more or less expensive than looking at the pets table, but basically, and notice I'll say select star from pets. Is there anything in pets where PID is equal to @PID? It is okay if you have these two names matching. It is also okay if they do not match. Many times I will match them in a case like this, but they don't have to match. So they could be completely different. The second, the one that is the variable has to begin with the @ sign because he is a parameter. So parameter names have to begin with the @ sign. Now I do not expect that you are going to, from this little blurb here, that you're going to be come in being a programmer. But this is what we will do. This is where we will start in ITSE 2347. Yeah, which is the next class. By the way, it has made, so shouldn't have any problem. I intend to Zoom the class. So if you you should have, it is not an online class. Okay, don't get the idea it's online, but it will support a remote attendance, like what you're doing now. So you would be able to listen in real time. I will Zoom it from the classroom at Preston Ridge, and I will post the recordings, but it is not intended to be an online class. Gets pretty complicated. Okay. Questions?
Hi. So this this programming portion that we're going to begin, what book is this, should we have for this? Because so far the bookstore's only got the same Murrock's 2016 book posted.
It's the same book.
That content's in here? Sufficient? Okay.
Now, well, it's not great, but then I don't know any that are great. So I'm going to have to augment it.
Okay.
You're going to augment it. It's going to be the textbook. We're going to use that. It is in here. If you look up the procedures, I don't think I have my book right in front of me. Yes, I do here, I think. Nope, that's Android programming. It's over in my backpack. I'm not. If you look under the table of contents under procedures, I want to say it's chapter 13 or something like that. And there's other things that we should do first. Usually before I get to procedures, I do if then else and looping, the stuff that you're expecting. If then else logic is pretty much the same in all programming languages. There's nothing really new here. Unless you're expecting it to do like C does, and if you say if 5, that's true. You can't do that in this language. So sometimes you have a variable, so x is equal to 5, and you say if x, well, that's true because it's not 0. And actually that's nice when you get used to it, but if you're not used to it, it is. In this language, when you say if, you have to say something if, something that's true or false, and exists is one of those words that we use a lot. So if there's anything there, and this is the cheapest way to test anything. Some people will say something like, they'll go out and they'll count all of the pets, and then they say if that count is greater than 0. Well, they had to go through and count everything. I can say if exists, if it finds one stinking little record in there, this is true, and it stops. So this is by far and away the stronger of the two. I'll show code that is not as good, because in this particular language, in these languages, you can certainly write very bad code. In SQL proper, most of the time, what you write is about as good as you can get, with some exceptions. But in TSQL, you can certainly write very inefficient code. And that's why we try to get people not to write using TSQL if there's any way around it. Lots of times there won't be. And the reason you use TSQL code, the reason you have it, is so that you can provide an interface to the web page. So these two procedures here would be the web interface to my pet owner's database.
Thank you.
Yeah. Well, ladies and gentlemen, this has been as much fun for you as it has for me. Well, I'm going to go ahead and end there. It is 6:52, so it's time for that to happen. I will make this file available to you on this should run. You should just be able to simply execute this. Let me try there. Execute. Oh. Yeah, if I didn't have something selected. So yeah, this runs as it is. And Um, I'll let you look at it and play with it some. And I'll go ahead and figure out where that stuff is on procedures. But usually I do a little bit of stuff before I jump right into procedures. So I usually will do the if then else. And by the way, you got looping and all that stuff. Everything you're expecting to find in a programming language, you've got in this language. Let's see, what don't you have? So you got a while loop. You do not have a for loop, but that's okay, because if I have a while loop, I can build a for loop. You do not have a post-test loop, but that's okay, I can build one. You don't use that very much. Very seldom do you do any looping. Most of the time in programming in this language, you're using if then else ladder logic. You're just going straight through it. You don't do much binary logic or anything like that. You're just starting at the beginning and going through it. But by the way you sequence that stuff, you can make it either efficient, very efficient, or very inefficient. And with that, I'm going to end.
Well, thank you. I did find the chapter. I guess I just feel like I need a little more detail, but I'll look online for some, because I've not taken any programming classes. So.
Okay. Have you had any C or Java or anything like that?
Nope.
Okay. Well, this you don't have to have had it. I will refer to it a lot and say, oh, this is just like it's done in whatever programming language. But programming languages will typically have an if then else logic, and they typically will have a looping logic. And so basically that's usually the first 6 chapters of a programming textbook goes into those. Okay, well, we'll see you then next semester, some of you.
Thank you. Well, and just even though I haven't had programming, I've worked with some proprietary languages. So they have some of the same foundations. Yeah.
Yeah, you should do okay.
Thank you. Thank you.
Okay, Ganesha. Good night, everybody.